Hello everyone, welcome to today's session. Welcome to Unacademy and welcome to classes. So in this session we are going to learn the very important concept sliding window protocol. Why it overcomes the problems of stop and wait we will discuss in this session. So before entering into the session, let us say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. As we all know, Unacademy has created a wonderful online platform with a good digital content, and it brought the dedicated students onto a single roof. So my dear friends, myself is Srinivasarao Sir, having more than 15 years of experience in the GATE with the various subjects in the computer science stream. I also had industry experience as a database admin and a system analyst. I also had a good industry certifications in networking side, database side, and operating system side. So my dear friends, throughout the journey of GATE, I taught in many premium academies with a high success rate. Many of my students completed their post-graduation from India's topmost premium institutions like IITs, NITs, central universities, and IIITs too. And they have settled in their life. What about you? Question mark yourself. So how are you going to fulfill your dear friends? All you need to know to clear the GATE examination and fulfill all your dreams is just it is possible with Unacademy only. So subscribe Unacademy either using a 12-month subscription or using 24-month subscription. So use my referral code, then I can able to the guide to you. I can able to give you guidelines how to write the examination and others till the completion of your GATE examination. And apart from the digital content, Unacademy is also offering a maximizer discount offer by using my referral code. My dear friends, utilize this opportunity what the Unacademy is providing, such that digital content and dedicated faculty members guidance as well as a maximizer discount. So my subscription, my referral code is also eligible for 12 months and 24 months, and also eligible for any kind of a course which is there in Unacademy. So my opportunity and to get the top quality content from top quality educators as you want to fulfill all your dreams, because your dream is our dream is Unacademy's dream. So my dear friends, please let us join all our hands to crack the GATE examination just by taking an admission into Unacademy. So to clear any doubts, if you are having, just to use this link and fill the form, then the faculty is going to guide you and clear whatever the doubts you are having. So let's crack GATE CSE is our YouTube channel. Subscribe our YouTube channel. Hit the bell icon for latest notifications and updates. Use my referral code Sankar to get the admission into Unacademy. Let us start, my dear friends, the today's topic, that is nothing but sliding window protocol. So why do we need a sliding window protocol? Why not we stick with a stop and wait protocol? Even though they are two belongs to the parts of your flow control protocols only. Why sliding window is a very famous than others? Because of two important points. What is the important point? Number one point is that the stop and wait protocol is best suitable for limited distance, suitable for lands. If you increase the distance, then the propagation time is going to be increased. Therefore, waiting time is increased. Hence, link efficiency and throughput is going to be decreased. And the second important point is that it is the best possible to fit only for the thin channels and not for the thick channels because of wastage of bandwidth. So that problem you can able to solve with the help of multiple data transmissions instead of a single data transmission. We know that stop and wait is going to do only one frame at a time, and we are waiting for the acknowledgement. What the sliding window is saying, instead of waiting for acknowledgement for the first frame what you are transmitted, and I am going to keep on transmission of my data frames. Therefore, there will not be any kind of waiting time at the sender side because the sender is performing multiple data transmissions without waiting for acknowledgement, which means during waiting of one particular frame, I am keep on transmitting my data frame. Therefore, you don't find that sender is going to be idle and medium is going to be idle. Both are busy in doing the transmission, and it also supports full duplex channels, so bandwidth is not wasted because we are performing a both ends transmission. If at all you are not having any data transmissions readily, then you can able to say that acknowledgement field you can able to send to specify to avoid timeouts. This feature is also there in your sliding window protocol. What is a real-time application of sliding window protocol? One of your real-time application is a data link layer. The other real-time application is a TCP, transmission control protocol. Why? Because it has got a wonderful facilities. Number one, no waiting time at the sender. Number two, link efficiency is 100%. So these two are enough. You can prove that this protocol is going to be work for longer distances. It can be used for WAN and MAN. So that's why it is not stick on to a shorter distance. It can be used for any kind of a network. That is the advantage with the sliding protocol. I will show you operation, how it works, and let us see that. What are the advantages? So efficiency can be increased. Efficiency can be increased, and sender waiting time is going to be 0 or very less. Why? Because it consider only first frame transmission time, and the next frame transmission times are being overlapped with the propagation time of your first frame transmission time. That's why sender is trying to overlap your transmission times and the propagation time. Therefore, my useful time is going to be very high. Hence, your waiting time is going to be 0. And what is the disadvantage? This is one of the limitation. So it is 100% not going to guarantee that the sender is 100% what I mean to say free from waiting time. So there may be a chance of some waiting time that I will prove with an example. That's why, my dear friends, apart from this particular assumption or a limitation, advantage is superb. It is eligible for full duplex channels, and it is also eligible for what? Longer distances channels. So therefore, what you need, everything are advantages only. So it is for full duplex channels, eligible for longer distance, waiting time is 0, so efficiency is increased. So these are the 4 important points we want to see that while you are comparing with stop and wait protocol. My dear friends, first let me explain what is the sender's behavior. Sender's behavior is, let me figure out. Now I am saying sender would like to use 2-bit sequence number. So this 2-bit sequence number will give you 2 power 2 total sequence numbers. So your total sequence numbers are 4, and your sequence numbers are starting from 0 and goes to n minus 1, which is nothing but 3. Now what is the one of the best advantage of your sliding window protocol? Sender can send multiple frames instead of transmission of one frame like your stop and wait. It's completely unlike to your stop and wait. That means sender can able to transmit a multiple number of frames. How many? I can choose. Before window adjustment I am telling you. Later I will adjust a window. Right now I can able to transmit 3 frames at a time because we are following 2-bit sequence number 0, 1, 2 and 3. So here receiver is also maintaining a 2-bit sequence number which is a 0, 1, 2, 3. So sender maintains SW and receiver maintains RW. So sender window consists of the frame sequence numbers, and the receiver window also consists of frame sequence numbers. So your sender window has got three parts. One part is buffer one, the other part is outstanding one, the other part is currently transmitting one. Please observe carefully. So now I am pushing the frame 0. So when you push the frame 0 from sender to the receiver using the transmission time, and this has to acknowledge by the receiver by taking this frame 0, and you will expect for next expected frame, that is a 1, and 2 and 3 have to come. So 0 is already acknowledged. When it is acknowledged, he will give a positive acknowledgement here, same like stop and wait only. So he is giving a positive acknowledgement that I want to have frame 1. Now here what is going to happen? According to the stop and wait, from here to here it is a waiting, but we will not wait in sliding window protocol. Why? Because you can able to transmit 4 frames at a time. That means your sender window capability is a 4, but receiver window capability is only 1. This is a common between your stop and wait and sliding window. We are trying to minimize the waiting time at the sender and increase the waiting efficiency of your sender. So your sender window size is a 4 because of this particular point. That means he will not free. He is a keep on transmitting the next 4 frames, 1 and next 2 and next 3 and next 4. So here what do we understand? Sender is not at all waiting for any type of acknowledgement. So during waiting time, I'm going to busy with the transmission. So what I said, your last frame transmission time is exactly equal to your first frame acknowledgement time. So my dear friends, so instead of waiting for acknowledgement, why are you sitting idle? Better you push all your data frames. So frame 0 and frame 1 and frame 2 and frame 3. As soon as you are sending a frame 3, the first acknowledgement is going to come. Observe carefully. The first acknowledgement is going to come for the first received frame. Therefore, this time and this time is going to be the same. So as soon as you got the acknowledgement of first frame, then immediately the next frame is trying to process, but I will not free. I am going to give you another frame, which is nothing but already 0 is being received. So I am going to transmit next 0. So next, soon after this got acknowledged, I am immediately transmitting 1 frame. Therefore, sender always maintains your window size is how much? 4. Please observe. Whenever you get acknowledgement for 1 frame, again immediately I am going to transmit a new frame. Therefore, there will not be any kind of waiting time at the sender. Sender is always busy in the transmission as long as he has got the data. Otherwise, he has to leave the connection. So what are the 3 parts of your sender window? The 3 parts of your sender window is already transmitted 1. For example, if I push frame 0, as you are having 4 frames in your window, 0, 1, 2, 3. So frame 0 already pushed, therefore it comes to the buffer, and next frame is supposed to be sliding is a 1, and remaining 2 are outstanding. Still they have to be transmitted. This is already transmitted. This has to be transmitted. Now, once you get the acknowledgement, please observe. So before you are transmitting acknowledgement from other side, then what the sender is going to do, he keep on transmitting another frame, that is a frame 1, then 1 will goes to the buffer. Now your buffer consists of 2 frames, that is earlier one 0, which is to be acknowledged, and the current one 1, which is also to be acknowledged. Now 2 will be sliding. So 2 will come into the current box, so it has to be slide. And your outstanding frame, which is nothing but 3. Now I will release F2 also. Then after that, this 2 will come to the buffer. Now your buffer consists of, observe carefully, earlier 2 frames 0, 1, now 1 more is added. Next, the 3 is going to be pushed to your current sliding path. So ever 3 is ready to transmit, it pushed. So as soon as you push the frame number 3, because here what is going to happen, the receiver might have received 0 and is giving positive acknowledgement. So whenever you get the positive acknowledgement, this time is exactly equivalent to the frame 3 transmission time. Therefore, once you transmit your frame 3, your window consists of 0, 1, 2, 3, which are to be acknowledged. Now, soon after you get the acknowledgement for the first frame, he has given a positive acknowledgement for first frame that it is a success. Next I am expecting frame 1, next I am expecting 2, next I am expecting to receive 3. Therefore, he has given acknowledgement 0. Once he has given acknowledgement 0, this 0 will be removed from your buffer and it is trying to add a new frame if you would like to further continue 0. Now the frame 0 is going to be transmitted and the frame 0 will be added there. And now the sender side, the sequence numbers are 1, 2, 3 and 0. Then after some time, you will get the acknowledgement for frame number 1. So he will remove the frame number 1 from your window because already it is acknowledged. He will push one more frame so that will come to the buffer. Now your numbers are 2301. Then after that, you are going to get acknowledgement here for the next expected frame, that is a frame 2. So when you get acknowledgement, this will be removed and the next number is going to be added, that is nothing but 2. So this is how the sender window shrinks as well as sender window expands. Sender window shrink means what? Initially, I have transmitted example C. Your sender window consists of 4 frame capacity initially. So when I say that my sender window consists of 4 frame capacity, your frame numbers are 0, 1, 2, 3 according to the previous example. So your window got 4 empty slots, 1, 2, 3 and 4. First of all, when you insert a 0 here, now window shrinks. Your free blocks are only 3. Your free blocks are only 3 only. So this is being filled. Then after that, 1 is filled. So your window shrinks to 1. Then after that, 2 is filled. Then after the 3 is filled, there is no room. You have to get acknowledgement to insert one more frame to your window. So now your window is completely squeezed and shrinks. When it is going to be expanded, when you get acknowledgement for first frame, that is a frame number 0, now you got one empty slot. Therefore, your window is expanding. You got one empty slot and the rest of the slots are free. So when you get acknowledgement for frame 1, so you got 2 slots free expanding and 2 and 3 are to be done. When you get acknowledgement for next frame, your window got 3 more frame slots. I can able to insert a new frames into that and still 1 is busy. So when you get a frame number 3, now window got to your original position consists of 4 blocks. That's why window shrinks as well as window expands soon after you got acknowledgement. When you release, window shrinks. When you get acknowledgement, window expands. So now let us see what is the sender's behavior. So sender's behavior is, sender maintains a sequence number of frames. It is permitted to send. I already discussed your n-bit value. Here I am taking as a 2, which means he is capable to transmit 2 power 2 frames, that is nothing but 4 frames. So prepare a new frame with a sequence number. Save a copy of your frame in the buffer of the sender's window. I already told you, your window consists of 3 parts. One part is a buffer, the other one part is a current one, the other part is a outstanding frames to be sent. So your window size is, why we have set from 2 power n to 2 power n minus 1. I will tell you to remove the ambiguity in the upcoming slides. So maximum number of frames the sender can send without acknowledgement is nothing but sender window size only. According to your window size, you can able to send those many frames. For example, earlier question I took 2, now I am taking n is equal to 4. So what is the sender window size? Your sender window size is nothing but 2 power 4, which is nothing but 16 frames at a time I can send. 16 frames at a time sender can send. So this is how you can able to judge that window size of your sender according to the last point. So maximum number of frames the sender can send is nothing but which depends upon your sender window size. Now let us see receiver's behavior. So receiver behavior is this last point. The saved copy of the frame is deleted whenever you get the acknowledgement. Otherwise you are going to maintain the copy into the particular sender window. I already told you about this, how to eliminate it. So once you get the acknowledgement, then the particular frame will be eliminated. Here 0 got acknowledged, so I remove 0. Then 1 got acknowledged, I remove 1. Then 2 got acknowledged, I remove 2. Now let us see receiver behavior. Receiver window size is always 1. He can able to receive only 1 frame at a time. So therefore, my dear friends, receiver maintains a sequence numbers of the frame next expected one, next expected to accept. So receives a frame and store its sequence number in the buffer. So sends a positive acknowledgement for next expected frame. Receiver window size is always 1. For example, if receiver receives a frame which is not equal to your expected frame number, then I can say that it is a duplication only, ambiguity. So the new frame is received successfully only when the sequence number of the current frame is not matched with the previous sequence numbers, otherwise which is not matched with your current expected numbers. For example, let us see, this is a sender, this is a receiver. So sender sends a frame 0 and frame 1 and frame 2. Now receiver start process the frames. Frame 0 is success. Now he is releasing the frame 0 acknowledgement. So 0 got completed. He is expecting next frame to be acknowledged is 1 only. So if I receive 1, I will accept. If I receive 0, then I am going to reject. That is that point. What is that? If your upcoming frame, the sequence number, if it matches with your window of number, then it is going to be said that I don't accept because it is a duplicate. So your next expected sequence number is supposed to be received exactly so that the receiver can able to receive it. Now, what is a window and how to calculate the window size in sliding window protocol? A window is nothing but consists of full of frames to be sent. Your window size depends on n-bit representation value. A window consists of 3 parts. I already discussed. First part is to be acknowledged buffer. Second part is currently sliding one. The third part is outstanding. So buffered frames and currently sliding numbers and outstanding frames. So let us see. Recently sent frames are stored in a window, nothing but a buffer with the frame sequence number. These frames are stored in the buffer unless and until you get the acknowledgement. Once you get the acknowledgement, I will remove that particular sequence number from your buffer. So once acknowledgement received, then that frame is removed from the buffer and the current frame is sliding. This is what is the meaning of a window at the sender side. So what is the sender sliding window? It can be shrinks, it can be expanded. So at any time, at any instance of time, the sender is permitted to send frames with the sequence numbers in a certain range. Window shrinks as well as window expands. Window shrinks whenever you transmit the frame. Window expands whenever you receive acknowledgement. So this is the behavior of your sender window, my dear frames. Whenever you are sending the frames, your window is filled with the frame sequence numbers. So whenever you get the acknowledgement, you got a one block free from your sender window. Now this is a very important. How to calculate the sender window size? This is also called as optimal sender window size to get 100% of efficiency. This is nothing but a simple equation. Your window of packets is nothing but your window of size divided by your frame size. That means window of packets is nothing but how many number of packets or frames you can send. It depends on window of bits divided by your frame size in bits. So this is how you can able to calculate optimal sender window size according to this equation. Otherwise, I can say that your answer is a what? 1 plus 2a. You can also do directly using a 1 plus 2a. 1 plus 2a is your sender optimal window size to get the 100% of efficiency. So if your efficiency is not 100%, then I can able to calculate using w by 1 plus 2a. So you can calculate according to like this, or you can also calculate using this equation. Window of packets are nothing but window of bits divided by your frame size. What is the window of bits? You may get a doubt. What is a window of bits? Window of bits are nothing but the capacity of the channel. So bandwidth into 2 into TP is your window of bits. So in that much data I can able to send. So I want to send this much data, therefore it is trying to segregate in the form of what? Packets. So I am going to explain one example. I say my frame size is equal to 100 bytes and my entire message size is equal to 1000 bytes. So dash number of frames you need. So your answer is 10 frames I need. So I am trying to split into 10 frames. Now look at another example. Channel capacity, your medium capacity is equal to, observe carefully, 1000 bytes. And my frame size also, same capacity, my frame size is also 1000 bytes. Now tell me, dash number of packets required. A dash number of packets required, just your answer is 1000 bytes divided by 1000 bytes, because your capacity is also 1000, your frame size is also 1000. That's it. I can able to transmit only one packet or one frame. So here I don't send multiple number of frames here because single shot is sufficient, one frame or one packet. But if he asks the question like this, sometime this is how you will ask in the examination. I say your channel capacity is equal to 1000 bytes and your frame size is equal to 20 bytes. He is asking dash number of sender window size. He is asking what is the sender window size. What is the sender window size? Simply I can write window of your capacity divided by window of your capacity is 1000 bytes divided by your frame size is nothing but 20 byte. So which is nothing but I need 50. So your window size is nothing but what? 50. That means 50 frames I can able to transmit. This is the window size. 50 frames we can able to transmit at a stretch. We can able to transmit at a stretch. So this is what is the meaning of sender window size. So in the previous example, your sender window size is equal to only 1. But here it is not the sender window size. I am calculating that how many parts of the data you are going to transmit. I have this much data information, but my capability is this much at a stretch. Therefore, you need to divide and transmit them. So 10 frames, first frame, second frame, third frame. This is how frame by frame I am going to transmit it. So this is how you can able to calculate your sender window size. Receiver window size is no doubt it is always 1. only one frame is going to be transmitted. So whenever you got, for example, I am expecting for frame number 4. Once you got the frame number 4, just that number will be pushed to the buffer, because I need to detect the duplication of the frames whenever the sender is transmitting. That's why you need to maintain these numbers, but I am able to receive only one frame at a time only. So this is a windows before receiving a frame 4. After receiving a frame 4, this is how it looks like, and the remaining one still you need to be what? Acknowledged. Need to be acknowledged. Well friends, how to calculate the link efficiency? This is another very important question. I have divided your sliding window portion into 4 parts. One part, how to calculate the sender window size. The other part, how to calculate the link utilization. Link utilization is very simple to calculate. How? If your window size is a greater than equal to 1 plus 2a, if your window size is a greater than is equal to 1 plus 2a, then your efficiency is 100%. If your window size is less than 1 plus 2a, then you don't get 100%. It is going to be lesser than 100% only. So your link efficiency is less than 100%. How much less than 100 means? Like this you can calculate. Your window size divided by 1 plus 2a, nothing but your total time. This is how you can able to calculate the window size. That means efficiency for the sender side. This is a very important equation. Now sequence numbers. This is a third part in the sliding window. So how the sequence numbers are designing your window size, especially in sliding window protocol. Let me do. So frames from sending stations are numbered one by one. But there is a need of limitation, your frame sequence number, which is a predefined we are going to set in the header. If the header of the frames or allows n bits, if header is allowing you to transmit n frames at a time, then I can send 2 power n, no doubt. I can send 2 power n, and those sequence numbers are from 0 to 2 power n minus 1. For example, if n is equal to 3-bit sequence number, it is allowing me only 3-bit. Then what is the frame sequence numbers you are having? 2 power 3 is nothing but 8 sequence numbers I got. What are your 8 sequence numbers? 0, 1, 2, 3, 4, 5, 6, 7. Because your sequence numbers starts from 0, ends with 2 power n minus 1 or n minus 1. Now, these are very important rules. What is that? Let me explain. If sender window size is equal to 1 and receiver window size is equal to 1, can you tell me what are the total available sequence numbers? Your total available sequence numbers are nothing but sender window plus receiver window capability bus. So sender window capability is a 1 and receiver window capability is a 1. So my total sequence numbers are 2, which is nothing but one is a 0, the other one is a 1. If I am saying sender window size is equal to 3 and receiver window size is equal to 1, what are your total available sequence numbers? Your total available sequence numbers are 3 plus 1, which is nothing but 4. What are your 4? It is 0 to n minus 1, almost all, my dear friends. Please observe. So 0, 1, 2, and 3. If I am saying your sender window size is equal to n and receiver window size is equal to 1, so what are your total available sequence numbers? Your answer is n plus 1. Clear? Now let me give you how to see that this one. I say total available sequence numbers is equal to 0, 1, 2, 3, 4, 5, 6, 7. He is asking what is the sender window and what is the receiver window. Sender receiver window is a 1 and sender window is a what? N minus 1. How much? All together 8 sequence numbers I have. So sender receiver window size is a 1 and the sender window size is a 7. Why 7? I will explain. I have just reset your sender window size from 2 power n to 2 power n minus 1. Why I have reset? You will understand. If I am saying n is equal to total available sequence numbers, then what is the sender window size? What is the receiver window size? So total available sequence numbers are 8. If I am keeping to n, it is n minus 1, it is a 1. Please observe every example. If I am saying another example, this is how you can calculate the sender window size using the sequence number. Because every frame is associated with sequence number only. I say total available sequence numbers are 0, 1, 2, 3, 4, 5, 6, 7. And what is your maximum sequence number from the above? What is your maximum sequence number from the above? Which is nothing but 7. That 7 is your sender window size. So receiver window size is always 1. Don't worry that. Now I want to put a question like this. If n is equal to maximum sequence number, if n is equal to maximum sequence number, what is the sender window size? What is the receiver window size? Receiver window size is always 1. What is the sender window size? Please follow the previous example. In previous example, maximum sequence number is 7. So sender can send 7 frames and receiver can send 1 frame. Therefore, SW plus RW is equal to 8 sequence numbers you got, which is 7 plus 1. That is equal to 8. Here also, when I say n is equal to maximum underscore sequence number, your sender window size is n only. N is nothing but your maximum sequence number 7 and receiver window size is 1 always. Please observe, my dear friends, 3 different examples I have given. One is, if I give you n bit sequence number, then how to calculate the window size? Like this, 2 power n minus 1 and receiver window size is 1. If I am saying that n is equal to maximum sequence number, your sender window size is equal to that much only. Your sender window size is equal to n and your receiver window size is equal to 1. If I am saying that sender window size is 1 and receiver window size is 1, your total sequence numbers are dot SW plus RW, which is n plus 1. And one more rule is there. What is that rule? If n is equal to total available sequence numbers, if n is equal to total available sequence numbers, then you tell me what is your sender window size and what is your receiver window size. Receiver window size is 1. What is your sender window size? Because total available sequence numbers, if I am taking 8, which is 0, 1, 2, 3, 4, 5, 6, 7. So sender can send only this much, which is nothing but your sender window size is how much, my dear friends? N minus 1 and the receiver window size is 1. Because the total sequence numbers are 8, if you consider 7 only can sender send in order to avoid the ambiguity. So we have set your window size from 2 power n to 2 power n minus 1. So this is one important point. If I am taking a big sequence number, there may be an overhead. I need to maintain that much buffer. Please understand carefully. For example, if I am saying 8-bit sequence number, if I am using, what is the 8-bit sequence number? The total available sequence numbers you take, which is a 2 power 8. which is nothing but 256 sequence numbers you got. Sender window size is only -1, that is a 255, and receiver window size is a 1. Therefore, you need to have a much more buffer capacity to store outstanding the frames which you have been transmitted. You need to maintain that much buffer size. Your window is this much. That's why instead of having that much overhead, instead of taking a very big long sequence number, we try to take the smaller sequence number only. The smaller sequence number also performs like this. So how? So to avoid the overhead, better you take the smaller sequence number. So if I use a 2-bit sequence number, then 2 power 2 is nothing but a 4. 4 sequence numbers you get. First sender will send 0, 1, 2. Then they are going to be reused. So your sequence numbers can be reused once you have consumed them. So this is nothing but wrap arounding of your sequence numbers. I may reuse the sequence number. So instead of taking such a long big sequence number, you can take the shorter sequence number. Therefore, you can able to reduce your overhead. What is the meaning of overhead? If I am maintaining a 256-bit sequence number, means that much you have to maintain what? Buffer capacity. Now sender window adjustment. This is another part of your sliding window. So some cases, first initially I started with sender window size is equal to 2 power n. Then I have reset it to 2 power n minus 1. Why? Now I am going to reveal the secret. Observe. Why we not send 2 power n? Why we must send only 2 power n minus 1? Please understand. So let us say n is equal to 2-bit sequence number. I am taking a very small one. So your total available sequence numbers are 2 power 2, which is nothing but a 4. The numbers are 0, 1, 2, 3, 0 to n minus 1. N is nothing but your last sequence number only. Now, sender started. So 4 frames, 4 sequence numbers are there. Every frame is going to be given a sequence number. So before sender transmit the data, you need to see that how many frames you need. Let sender need 4 frames to transmit. This is his requirement. He wants to only 4 frames to transmit. I have got sufficient numbers, 4 numbers I have got, right? So he started sender window. His capability is a 4. How did you get his capability? 2 power 2 is equal to 4. So directly I am sending 2 power n. What will happen? Let us see. So I am saying that you are capable of 4. That too you want to transmit only 4 frames only. So that is first 0 is issued. It is transmitted. Then frame number 1 is issued. That is also transmitted during waiting time of the first frame. Observe, my dear friends. During waiting time of the first frame, I am going to transmit the data frames continuously. Still I have the capability. Still one more number is added. Frame 3, frame 2, frame 1. You assume that receiver received all the frames successfully. 0 success, 1 also success without error. Success means there are no errors. And 3 also success. Now he is sending acknowledgement. Acknowledgement for frame 0 positive. Acknowledgement of frame 1 positive. Acknowledgement of frame 2 positive. Acknowledgement of frame 3 positive. Yes, sender is happy now because he has sent 4 frames and 4 frames got response. I feel that my data transmission is successful. Right? Now I am increasing the number of frames you want to transmit. I want to say that he wants to transmit 8 frames. Please observe. Now initially this is your first set. First set of 4 frames. Once you get the acknowledgement, please understand. Once he get the acknowledgement, then he is ready to transmit the second set. What is your second set? I am changing the font color. Observe. So for 0 acknowledgement, I will send 0, and for 1 acknowledgement, I will send 1. No doubt. This is your second set. As you already received the acknowledgements, they will be removed from the window, and you are adding a new frame sequence number 0, 1, 2, 3. Because 8 frames means 8 sequence numbers you will get. Don't write that 0, 1, 2, 3, 4, 5, 6, 7. You are limited to 0, 1, 2, 3 only. Those numbers are reused. Now he is transmitting 0, 1, 2, 3. So second set, frame 0, second set I am writing, and frame 1, and frame 2, and frame 3. Frame 0, and frame 1, and frame 2, and frame 3. It's fine, no doubt here. Let me write the example in different way. I'm saying n is equal to 2-bit sequence number only. Same like that only I am writing. So your total available sequence numbers are 2 power 2, which is nothing but a 4. Your capability is only 2-bit sequence number, which is defined in the header of your frame. Now sender window size, I am taking full 2 power n, 0, 1, 2, 3. I can transmit 4 frames because it is defined like this. Please observe this case. Frame 0, frame 1, frame 2, frame 3. His requirement is total 8 frames. Total 8 frames to send. So what are the numbers? 0, 1, 2, 3 one set, and 0, 1, 2, 3 another set. 2 sets of numbers. Now receiver side, let us see. Receiver is taking first frame 0 success, 1 success, 2 success, 3 success. Now he is giving acknowledgement. Positive 0, positive 1, and positive 2, and positive 3. We assume that these are lost. All the acknowledgements are lost, and the sender is waiting for acknowledgement. Then only sender will understand that my first set of frames are success, but actually they are success only. Actually they are success. 0, 1, 2, 3 already out of buffer. You are expecting for next set 0. Please understand carefully. You are expecting for next set 0, 1, 2, 3. These are already acknowledged, but acknowledgements are lost. So when acknowledgements are lost, sender feels that I have not received acknowledgement. I thought my data frames are lost. So data frames are lost. He guess. This is the guess of sender. Then what a sender is going to do? Please you can comment me. What sender is going to do? Will he send a new 1, 2, 3, 0, 1, 2, 3, or will he retransmit 0, 1, 2, 3 old frames? This is your old, and you are about to transmit a new frames 0, 1, 2, 3. This is your second set. But I will not transmit a new frames 0, 1, 2, 3. Why? Because the old frames are not acknowledged. What sender is going to send? He is retransmitting once again 0 and 1 and 2, 3. That means instead of sending a new frames, he is sending a old frames only. Now tell me, receiver is expecting, please observe, your sequence numbers are 0, 1, 2, 3, they have been retransmitted. Receiver is expecting 0, okay, matched. Receiver is expecting 1, okay, matched. Receiver is expecting 2, matched. Receiver is expecting 3, matched. Then he will accept them. But he accepted duplicate data frames. But he is thinking that I am receiving a new frames. But you observe that this is also old frames only. And these are also old frames only. Your message got duplicated here. So this is the ambiguity. So to avoid the ambiguity at the receiver side, you don't send 2 power n. You please send 2 power n minus 1 only. This is the slide sender window side adjustment to detect the ambiguity. So now let me explain the same example like this. So total 8 sequence numbers I am taking, sorry, total 8 frames to send. Observe my dear friends, total 8 frames to send. But unfortunately your n value is a 2-bit sequence number. So you are limited to use sequence numbers. So your available sequence numbers are 2 power 2, which is nothing but a 4, 0, 1, 2, 3, which is telling you that your capacity is not 8, your capacity is only 4. So you start transmitting first 0, 1, 2, 3 only, but your frame sequence numbers are 0, 1, 2, 3, and the second range is 0, 1, 2, 3. This is your first set, and this is your second set. Now let us transmit with the same assumptions. So first 0 is being pushed, then 1 is pushed, then 2 is pushed. We will not push all. We are going to push only what? Your sender window size is adjusted to 3 from out of 4. Earlier is I have taken completely 2 power n. I have taken 2 power n is nothing but 2 power 2. That is nothing but 4 is your window size. But here now your window size is a 2 power n minus 1. That is nothing but 2 power 2 minus 1, which is nothing but 3. That means you are able to transmit only 3 frames at a time. 3 frames means n minus 1 frames only. So your till to stand is 3. So let us see the receiver side. Receiver received frame 0 success, 1 also success, 2 also success. He is expecting next time expecting 3. This is expected frame. Now he is raising the acknowledgements. Frame 0 got acknowledged, and frame 1 also got acknowledged because it is a success. Frame 2 also got acknowledged. We assume that, we already guess, these acknowledgements are lost. So when acknowledgements are lost, sender is retransmitting 0, 1, 2 once again. 0 and 1 and 2. But receiver is expecting what is the number, my dear friends? Receiver is expecting 3. Therefore, 0 go there and checking that you are not matched to me. And 1 also go and match there. It is also not matched to me. And 2 also see that it is also not matched to me. Then receiver says that they are duplicates. This is how the receiver is providing a facility to detect the duplication of the frame at the receiver. That's why your 2 power n is adjusted to 2 power n minus 1. Understand, my dear friends? This is how the sender window size is adjusted from 2 power n to 2 power n minus 1 to detect the ambiguity of the frames for the receiver side. So that's the point. So I need to send actually 2 power n, but I am not sending 2 power n. I am restricted to 2 power n minus 1 to take the duplications at the receiver side. Now, so it is going to provide all 3 varieties of acknowledgements. Independent it will support, cumulative also it will support, and piggybacking also it will support. All 3 varieties of acknowledgements it can support. But every individual acknowledgement, that means every particular group of acknowledgement has got its pros and cons. If I am using independent acknowledgement associated with n packets, that means already I shown you in the previous example, 0, 1, 2, 3, I have pushed 3 frames, 0 and 1 and 2. If I am using independent acknowledgement system, I need to give acknowledgement for 0, I need to give acknowledgement for 1, and I need to give acknowledgement for 2. This is what is the meaning of independent acknowledgement. Every frame is associated with a one acknowledgement. Therefore, traffic is very high. You are sending data, he is also sending acknowledgement for each and every frame which he received. That's why traffic is high, but reliability is very high. Why? I will come to know that whichever frame is a lost and whichever frame is a success. For success frame, I will send positive. For failure frame, I will send what? Negative. That's why its reliability is also very high. That is the advantage with independent acknowledgement system. Cumulative acknowledgement system is associated with n plus 1 frames. I will show you. 0, 1, 2, 3. So sender is now able to send only 3 frames only according to the window adjustment. So sender push frame 0 and frame 1 and frame 2. He received 0 successfully, 1 successfully, 2 successfully, expected 3. Then instead of giving 3 sequence numbers, acknowledgements, he is giving only 1 acknowledgement that I want 3. What is the meaning of 3? You are expecting frame 3, which covers that the previous numbers are success. N minus 1 success, N minus 2 success, N minus 3 success, as I am waiting for N. N minus 1 success, N minus 2 success, N minus 3 also success. So only 1 acknowledgement for earlier frames. So traffic is low, but what is the problem? Reliability is also very low. Why? I will show you. Observe. So sender transmitted 0, 1, 2, 3. That means he cannot send 0, 1, 2, 3. He can send only 0, 1, 2. 0 pushed, 1 pushed, 2 pushed. I am using a cumulative. Cumulative means only 1 acknowledgement for group of frames. That's the meaning of cumulative. N plus 1 you need to give. 0 success, 1 is lost, 2 is lost. Now tell me, what is the acknowledgement number you will give? If you give positive 3, you are agreeing that, please understand, if you give positive 3, you are agreeing that all 3 are success. They are not success. So here you cannot give what? Cumulative acknowledgement system. Cumulative acknowledgement system only for error-free channels. But erroneous channels, whenever you know that there are some errors may be occurred, so frames are going to be lost, you cannot use a cumulative. How to use independent? See the beauty of independent acknowledgements. I will solve your problem. So I have transmitted 0, 1, 2. So 0 is pushed, 1 is pushed, and 2 is pushed. As we guess 0 is success, so I will send positive, and we know that 1 and 2 are lost, then I will give negative acknowledgement for 1 and negative acknowledgement for 2. This is the advantage with independent acknowledgement system as comparatively to cumulative acknowledgement system. It's not reliable. And the third acknowledgement system is a piggybacking. So what is a piggybacking? So your acknowledgement is attached with your data. I am not going to send a separate frame for acknowledgement. I am going to attach my acknowledgement to your data. Embedding of your acknowledgement with your data frame is the concept of what? Piggybacking. This is the mostly used in a full duplex channels where sender and receiver is sending data and receiving data. So in that case only you may use the piggybacking concept. So this is the piggybacking concept. What is that? Sender is sending a frame as well as sender is sending acknowledgement. He will send the frame as well as he is asking you acknowledgement also. He also other side. He will send the frame and he is also asking for what? He is also sending what? Acknowledgement. This is how both your acknowledgement data is embedded with your data frame. It is called as a piggybacking. Mostly we use in a TCP because a TCP acknowledgement system is a what? Piggybacking. So my dear friends, now I will start a limitation of this. What is the limitation of sliding window? Please observe. Sliding window, I said that it is going to give you 100% of efficiency because no waiting time at the sender side. No waiting time at the sender side. But it is not always true because if, please observe, n bit sequence number is, if n bit sequence number is less than your 1 plus 2a, then your sender window size, your sender window size is your 2 power n minus 1 only. So you cannot use a 1 plus 2a. So 1 plus 2a, whenever you are using, you are going to get 100% of efficiency. But whenever you are restricted, your n bit value is lesser than your 1 plus 2a, your sender window size is a 2 power n minus 1. Therefore, you cannot get 100%. So in this case, and no, so we will not get, your link efficiency will not be 100%. So what is your link efficiency? Your link efficiency is how much you can send divided by your 1 plus 2a. Why this is come? What is the proof? I will show you the proof. Now let us see. N is equal to 2-bit sequence number. N is equal to 2-bit sequence number. I am asking you, what is the sender window size? 2 power 2 minus 1, which is nothing but 3. What is your receiver window size? It's 1. This is one example. Now let me give you one example here. For example, transmission time is equal to 1 ms. Very, very important example, my dear friends. Before going to exam, you need to once go through them. And TP is equal to 4.5 ms. He is asking, what is the sender window size? How to calculate? Here he has not given any n-bit sequence number to calculate, but how to calculate? How to calculate? I said a reason and a rule. What is that? Your sender window size is nothing but 1 plus 2a. This is the direct answer you please use in the examination. What is a? Your a is nothing but TP by TT. So what is your TP? 4.5 ms. What is your TT? 1 ms. So your answer is, sender window size is a 1 plus 2 into A. A is nothing but 4.5. So your capacity is a 10. What is the meaning of 10? 10 frames at a time. I can send. Sender can send. This is a second variety to calculate the sender window size. If I am saying, please observe carefully. According to the previous example, I can send 10 frames at a time. Please see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 sequence numbers I am taking. So I am pushing 10 frames. Frame 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why I am writing these many? You have to ask me why I am writing these many. Let me explain once again before writing these many. First of all, I will send frame 0. When you send a frame 0 using a 1 ms time, because your TT is 1 ms, observe. Your transmission time to push a frame is a 1 ms. But after pushing the 1 ms, it has to go there and coming back. It is taking almost all, how much? 2 into 4.5 ms time to get the acknowledgement. That is the meaning of TP. TP is nothing but one side propagation delay, and TP is nothing but other side acknowledgement propagation. How much time I am taking? 9 ms I am taking. So your 9 ms is your waiting time only. Your 9 ms is waiting time. But I will not wait. Sliding, this is a stop and wait. But I will not wait. What I am doing? I will push. This is a frame 0 he pushed. What this guy will do? He keep on push. Frame 1 and frame 2 and 3, 4, 5, 6, 7, 8, 9. All frames he is pushing. Now you tell me, what is the sender window size? Your sender window size is nothing but 1 plus 2a. As much, this is your total time. So therefore your sender window size is 1 plus 2a, which is nothing but 10. I can send 10 frames at a time because my waiting time is a 9. Why to wait unnecessarily? I will push 9 more frames. Earlier one and this one 9, and 1 plus 9, 10 frames at a time they have been pushed. That's why waiting time is a 0 here, because I am not at all waiting. If I say another example, according to the previous example only, I am taking n is equal to 2-bit sequence number. I am not saying TT, I am not saying TP. Directly I am asking, what is sender window size? Our answer is 2 power 2 minus 1, which is nothing but 3 frames at a time. You can send at a time 3 frames only. That means frame 0, frame 1, frame 2 and frame 3. But your TP time is how much? Acknowledgement time of your frame is how much? Please understand carefully. Acknowledgement time of your frame is how much? First frame. That is 4.5 ms I said according to the previous example. So 4.5 ms is your TP. Let me give your TP is equal to 4.5 ms, comma. So you are capable to send only 3 frames, but the first frame got acknowledged only after 2 into 4.5 ms. Your first frame got acknowledged 2 into 4.5 ms only. That is nothing but your acknowledgement takes 9 ms. So first frame I send, frame 0. So remaining is your 9 ms is your waiting time, right? I am not going to wait. I am pushing. This is already pushed. I am pushing frame 1 and I am pushing frame 2. Can you able to push anything? No, you cannot push. Why? Because your capability is only 3 frames according to this restriction. Because n bit value is restricted you not to send 10 frames like the previous example. So therefore, what happened? So during this 9 ms and first your 1 ms time, during 10 ms of time, I have pushed only 3 frames only. Therefore, it is not completely free from waiting time. So what is your waiting time? Please understand. Your total time is TT plus 2 into TP, because the first frame transmitted is with 1 ms and my waiting time is a 9 ms. If I send 10 frames, okay, my waiting time is 0. But I am not sending 10 frames. How many I have sent? Observe carefully. Your total time is equal to 10, but you have transmitted only how many? 3. You are still having a what? 7 units waiting time. That's why the sliding window protocol is not completely free from waiting time. Because why? Your n bit value is less than your 1 plus 2a. What is your 1 plus 2a? I already told you. Please understand. If sender window size is greater than is equal to 1 plus 2a, then no waiting time. And link efficiency is 100%, no doubt. Or your 2 power n minus 1 greater than is equal to 1 plus 2a, then I can say here also no waiting time, because I can able to send those many frames. So your efficiency is 100%. So here also no waiting time. First point and second point. But limitation, what is that? If sender window size is less than 1 plus 2a, then problem starts. Then waiting time is there, then efficiency is not equal to 100%. How much it is? Your sender window size divided by 1 plus 2a. That's why sliding window protocol is not completely free from what? Waiting time. There is exception. This is only exception. If n bit value is restricted you not to send completely up to 1 plus 2a, then your waiting time is there mandatory and your efficiency is also going to be down. I will show you another example. Before closing the session, please understand, my dear friends. I say n is equal to 5-bit sequence number. And your 1 plus 2a is equal to 25. What is the efficiency? So we know what is the efficiency. Your n bit value 2 power 5 greater than is equal to your 1 plus 2a. So whenever your sender window size or your n bit value is greater than is equal to 1 plus 2a, my efficiency is 100% and my waiting time is equal to 0. If I shift these values reverse, I am saying n is equal to 5-bit sequence number and my 1 plus 2a is equal to 16 only. That means you can send only 16, not the 2 power 5 minus 1, 31. So here what is going to happen? He is asking what is efficiency. So what is L of u? Now your L of u is nothing but not 100%. It will be less than 100% only. Why? Because your 2 power 5 what is this? I want to say 64. So your 2 power 5 not greater than is equal to your 64. So how many you can send? So you can send only this much. So you cannot send always this much. Therefore 2 power 5 minus 1, which is nothing but 31 only you can send out of 64 units of time. This is your efficiency. So why that is happening? I will give you a proof. Observe. I am saying n is equal to 3-bit sequence number, right? Your 1 plus 2a, that means data will go there and getting to be acknowledged time is your 1 plus 2a, which is nothing but 8. So you observe now, can I able to send all frames or not? Your first frame got acknowledged exactly 8. Now how many I can send? You can send according to that 2 power 3 minus 1, 7, 0, 1, 2, 3, 4, 5, 6, 7. So I can send 0 to 6 because 7 frames at a time. So according to that, every frame got frame sequence number. Therefore, I can able to send. So frame 0 I can push, 1 also push, 2, 3, 4, 5, 6, 7. 6 only I can send, 0 to 6. Therefore, what do we understand? Every frame got acknowledged. Every frame got a frame sequence number. Therefore, I can able to push. So here, 100% efficiency. No doubt. Because your 2 power n is greater than is equal to 1 plus 2a. No doubt. So 100% efficiency here. If I say reverse, n is equal to restricted to 2-bit sequence number, but my frame got acknowledged only 8. 1 plus 2a is 8. Now let us see what will happen. So how many you can send, my dear friends? 2 power 2 minus 1, which is nothing but 0, 1, 2 I can push. 0 is pushed, 1 is pushed, 2 is pushed. But when 0 is got acknowledged, 0 is got acknowledged only at 4 ms this side and 4 ms this side. So remaining time is a what? Waiting time. Why? I don't have frame sequence number to push. Even though I want to send frames, but there are no numbers are allocated. That's why you cannot insert the frames to send. What is the meaning of that? Please observe. Sender can send two ways. Sender can send either 1 plus 2a, comma 2 power n minus 1. What is the minimum? That only is going to send. This is a very, very important question. Why? If you are having infinite sequence numbers, but I cannot send those much because within the acknowledgement time only I could able to send. That I will show you. For example, n is equal to 4-bit sequence number, but my TT is equal to 1 ms and my TP is equal to 1.5 ms. So what is sender window size? Anyhow, receiver window size is always 1. Our worrying sender window size only. Let me tell you the solution. So your sender window size is 2 power 4 minus 1, which is nothing but 15 frames at a time I can send. Can I send? So can I send or not? That depends on your round trip time. Please observe. Whenever you push the first frame using frame 0, it is going to get acknowledged. You have transmitted with 1 ms time. This is acknowledged after 1.5 ms and 1.5 ms. That means 2 into 1.5 ms is nothing but 3 ms. That means your waiting time is only 3 ms only. That means I can send only 3 frames. Please observe. Because within the first round trip time only I can able to fulfill. My waiting time is only 3, not infinite. But you have got 15 sequence numbers. Can I send? No. You can send only 3 frames only at a time. Therefore, what are you sending here? Are you sending 15 or 3? We are sending minimum. What is the minimum? Minimum of 2 power n minus 1 comma 3. So 3 is nothing but what? Your 1 plus 2a. Either this value we need to send. So here, what is the minimum? This is the minimum. That's why we are sending 1 plus 2a only. What is your 1 plus 2a? Your 1 plus 2a is nothing but 1 by 1 plus into TP by TT. 1.5 ms by 1 ms, which is nothing but what? 4. That means I can able to send 4 frames here. So you cannot able to send all the frames. Now come to next example. This example is n is equal to 2-bit sequence number and your TT is equal to 1 ms and TP is equal to 19.5 ms. So your solution is, you decide your sender window size is this or this. Or one more way to find the sender window size, 1 plus 2a, which is nothing but 1 into 19 plus 19.5, 39 plus 1. It is a 40. Now you tell me, will you send 40 frames or you will send only 4 frames? I already gave you the rule. What is that? Minimum of your 2 power n or 1 plus 2a we are going to prefer. Here this is the minimum, so I can send only 4 frames. So what is the proof? Please observe. So the first frame got acknowledged only after 39. Please understand. First frame got acknowledged after 2 into TP time, which is nothing but 19.5 ms one side and 19.5 ms other side. So I push frame 0. I push frame 1. I push frame 2. I pushed frame 3. I don't have numbers. Please observe, I have got only 4 numbers only. So remaining time you cannot send, even though you are getting acknowledgement by late, because your sequence numbers are not supporting to you, and the remaining time is going to be what? Waiting time. So always you need to take equation that minimum of 2 power n comma 1 plus 2a you need to choose. So according to whichever is the minimum, that one. If earlier one, excellent, 100% efficiency you are going to get. Why? Your n bit value is greater than is equal to your 1 plus 2a. Observe that. Your n bit value, that means I will write here. Why you got 100% of L of u? Because your sender window size, observe carefully, your sender window size, 4-bit sequence number, which so 2 power 4 and 1 plus 2a. So 2 power 4 is a 16 numbers, 1 plus 2a is a 4. So your sequence numbers are greater than your 1 plus 2a, hence 100% efficiency. Please understand here. If your window size greater than is equal to 1 plus 2a, efficiency is equal to 100%. But next example I shown you. What is that? This is the example. Here n-bit sequence number is lesser than your 1 plus 2a. That means if window size is less than 1 plus 2a, then your efficiency is lesser than 100%, less than 100%. So how much it is? Window size by 1 plus 2a is a newly calculated efficiency. So your window size, according to the previous example, please understand. According to the previous example, my window size is how much? 4, but you got acknowledged how much? At 40. So your answer is 4 by 40 is your efficiency, which is nothing but 1 by 10. So here you got 100% efficiency. Here you got what? Efficiency is lesser, which is nothing but 1 by 10, because your window size is less than 1 plus 2. That's it, my dear friends. So this is how you can able to see that sliding window protocol is a far better than your stop and wait. But sliding window protocol, there is a limitation that there may be a chance of waiting time whenever your window size is less than 1 plus 2a. If window size is greater than 1 plus 2a, no doubt 99.99% you get 100% efficiency. Very limitation as like this. If window size less than 1 plus 2a, then your efficiency will not be 100%. Your efficiency will be window size by 1 plus 2a. Window size means how much, my dear friends? So I am taking directly 2 power n. Actually, it's supposed to be 2 power n minus 1 by 1 plus 2a. This is your answer. Please do this one in the example, because sliding window protocol is adjusted from 2 power n to 2 power n minus 1. It's not 4, it's a 3 only. Okay, my dear friends. So thank you very much for the cooperation. So tomorrow we will discuss on YouTube the problems of stop and wait and sliding window protocol together. Then you will understand that how to do practice problems. Please use my referral code to get the admission into Unacademy for further lectures, because I can teach multiple subjects in GATE. So if you take my referral code to get the admission into Unacademy, then I can be your guide. You can be my scholar. I can able to guide you. Thank you very much. We will meet in the tomorrow's 2 p.m. to 3 p.m. class, that is Unacademy special class on sliding window protocol questionnaire, and 10 p.m. to 11 p.m. class and flow control problem practice stop and wait and sliding window. Thank you very much. Good night.